are investigating a very new model. We have a number of variables there, and we have a smaller number of unobservable factor, and we just make into a conceptual framework. Accordingly, we use the EFA or factor analysis. So EFA versus CFA. EFA is the exploratory factor analysis. Uh, the CFA is the confirmatory factor analysis. So I mentioned as earlier that confirmatory factor analysis is used when we have a proper scaled, and already there is literature available about any variable and their scaled paper. We use the confirmatory factor analysis, while when we just explore the factors, we don't have any idea what is the conceptual framework, and what are the variable we will include, and what is the correlation between that variable. We use EFA. So EFA is EFA, as we can take a first step. So we just, whenever we start with the problem formulation, we first collect what will be the variable, and on the basis of that we draw the conceptual framework. So EFA is about exploring all the factors. So in factor analysis, whenever we conduct the factor analysis, we first use the Kaiser-Meyer-Oakland, that is KMO measure, for sample adequacy, where we confirm our sample adequacy, or it is on the basis of uh, alpha, and it is above the point 0.5. Next is the Barley test. It is basically a test used to examine the hypothesis that variables are uncorrelated in the population. So the value is for the KMO is 0.5, and Barley test is also for the 0.5. Next is the commonality. Commonality is the amount of variance share with all the variables being considered. This is also the proportion of variance explored by the common factors. Okay. Next, we will use eigenvalue. The eigenvalues represent the total variance explained by each factors. Then we mentioned the scree plot. It is same as we use for the eigenvalues. Next, we will use the factor loading and the factor matrix. After that, we use the varimax rotation to confirm our variables. So the process of conducting the factor analysis is step one. In step one, we will use the problem formulation. As I told you, this is the step one where we find out the problem formulation. You can use the traditional method for identifying the problem, as you can take your favorite subject. You just go through with the syllabus, and you just pick it at one, and you just find out what is the problem formulation. Or in the modern method, which I recently explored, that you just first see your respondent, whatever you want to do the research. As I belong to higher education, so I personally have the interest about the higher education, faculty's problems, students' problems, and after that, you just select your favorite topic and align with them. Then next, EFA requirements. What are the EFA requirements you need? What are the conceptual variables you trying to include in your conceptual variables? Then use the factor techniques, and you need to when you run the factor analysis, you automatically come through about the decision regarding the number of factors, and the last is the factor rotation. So as I told you, I suggested to my scholars to take uh, either the traditional method to identify the problem formulation, or the modern method, where I first include my respondent, um, to take that respondent, and on the basis of I'm just doing entire research, and then I align my favorite topic to them, and then I make entire research concept. So I also give one example to you guys. As At the time of my PhD, one of my junior told me that, ma'am, I have a problem regarding the data analysis, and this is directly impact to my research performance. So I said, ki we have YouTube's, that time in I'm talking about the 2019 time. That time there is no AI. Only we have the YouTube. So that time we have only some uh, some internet facilities there. So before Corona, the internet facilities uh, are not well structured in India. So excuse me. So I suggested my my junior that to use YouTube, and she said no, I have a problem to use that. And same, I talked to my colleagues as well. They are talking about the same thing, that we have a problem. So I just confirm, and that topic click in my mind, and I make the research on the digital competency, and it is linked to the research performance. It is published in Journal of Applied Research in Higher Education in Emerald. So you just come across your respondent and identify their problem, talk to them, and first identify what are the problems they are continuously facing. So on the basis of that, you do the research. So it will automatically um, boost your research, and it helps you to publish in a good journal. Then EFA requirement, you just identify whatever the conceptual variable, and then run it with the SPSS, find out their KMO values, Barley test value, the commonalities, and then use the Varimax rotation. I told you about that. Then identify the number of factors through eigenvalue, script plot, and the Varimax rotation. And Varimax rotation we have conducted. So I just quickly take you to my SPSS. So far, any question?
Madam,
Yes.
I just give you one question, maybe not very directly related. Some particular expert, when presenting our papers, they generally, better to say, told us or motivated us to go for data cleaning and data dependency and all the things. And for that, if it is important to know the heteroscedasticity level or something like that, should we go for all these things if we have to conducting if we are to conduct this EFA? I think these are not very related, but they sometimes they tell to go for all these checks and then conduct an EFA.
Sir, it is about what is your aim to do this. So, if you want to conduct in your research EFA, you just first check what are the values are coming. If they are in the criteria, then you are good to go. You don't need any data cleaning and data heteroscedasticity, whatever you are saying. If there is a problem in your data and the values are not coming in the criteria, then there is a possibilities of you are not having uh, you are not having the good data, and you need to clean the data and then check the standard deviation first, then see as I earlier mentioned that
A normality test.
you
Okay.
just do the normality test first. Okay, so you will do these things and then uh, make the decision, then whatever you use in your research. Okay, but if this is your first research paper, then I told you I will suggest you that to go for the confirmatory factor analysis, because it is very easy to conduct any research. EFA is little bit difficult, because here we need to conduct the EFA, that is exploratory factor analysis. Then we need to conduct the confirmatory factor analysis. Both we need to conduct in one research paper. So if this is a paper, this is first paper for you, then you go for the confirmatory factor analysis. And if you are very new in this field, I will suggest you to do the literature review paper. Okay, so literature review paper give you understanding or insight about all these things. So just आप देखें कि आप कौन से स्टेज पे हैं. Okay, and accordingly you just do your research.
Yes,
Okay.
yes. Thank you, madam.
Okay, sir. Okay. So this is the SPSS, and it is similar to Excel, but it has a very advanced skill. Um, we have here data view and the variable view. Okay, um, this is the label. Okay, you just mention the label whatever your question is required. Okay, and then you change the measure here, as it is you just first need to understand what is nominal, ordinal, scaled. So I'm sure you all know about this. If you don't know, then let me know, so I will give you insight about this. all are aware about the nominal, ordinal, and scale. So we need to scale up the data, and whatever your question requirement, you mention here your standard size here, sorry, your scale or nominal according to your question. So as we have some changes, we have put some changes here. So first you need to go to analyze, then dimension reduction. Here you may see there is a factor. Now you just put your entire variable here. Then check the descriptive. As I mentioned, we need a KMO and the barrel test. See, if you need if you need your factors um, which are uh, having the greater than one, all they show, or if you need um, any fixed number, if you have any fixed number, then you can mention here. So as I have variable 1 2 1 2, let's suppose that IF, UP, GF, TF, and R are directly lead to ED or directly affecting the ED. And I told you about the exogenous variable and endogenous variable, that are the independent and dependent variable. So I'm sure you have some knowledge about the independent and dependent variable. So here the ED has a dependent value, and these all are IF, UP, GF, TF, R, and ED has independent value. Okay. So we just analyze dimension reduction. We have descriptive, KMO, continue, extraction. We can fix here. We need a 6 variables. Only we need 6 variable. Here we can use the Varimax rotation. Score, we don't need to change. And suppressed is small coefficient. So it means that you need you need to set the criteria of your variable. So here I'm uh, taking 0.5. Okay, continue. I'm not selecting here. Okay, Okay. So Kaiser Meyer Oakland shows 0.920, and as a criteria we have we will select only the values which are coming 0.7. Okay. So 0.7 is the setting criteria, and we have 0.90. That means we have a good sample adequacy. Then we check the barter test. This is 17471. This means that we have the correlation matrix. Okay. Then commonalities. These are 0.7. So you can use all the six as you have here. See, ED has 0.569. So maybe it will create a problem in further matrix. But as of now, we will take this. As I mentioned, I need only the values, eigenvalues to six variables. That means they are confirming that I have a six variables. Then see, each, this is Varimax rotation, and um, you need each variable define each here variable. So as this is creating the problem, because there you see the number one variable is defining in IF, UP, GF, TF, R, R3, and ED. And ED here is also shown to second and fourth. So what I need, that we need to clean the data again, and we need to run, and we run it till there the differentiate in the values, like the IF factors is come in one factor, UP one in come in second factor, GF in third, and so on. Okay. And this is the rotated component matrix. As you can see here, it shows like this, but it needs like यहाँ पर पे भी same वो चीज show होनी चाहिए. ठीक है. So here you mention we have T in T in 6 as well, T in 1. तो यहाँ problem है. But you see, all the variables are having having the values of 0.7. But as I told you, ED has a problem. Commonalities में भी थी, यहाँ पे भी है. ED has a problem. ED 1.569 here in 5 as well. So it shows in this as well. Here it mentioned that 5 is 0.6, ED1 is 0.656, 656. So this is the rotation component matrix, and you see the variables are showing in different variable. That means they are showing the correlation. Okay. So IF has a correlation to 4 factor. Number 4, UP, all the UP has a correlation to 2. Then GF has a correlation to 1, GF and TF. So here this is some problem. GF and TF both are showing the correlation in 1 factor. Okay. Then again, TF is showing the correlation to sixth variable as well. Then R is showing the correlation to 1 and 3 as well. Are you with me? Are you getting what I'm trying to mention? Hello, am I audible?
Yes, ma'am.
Are you getting what I'm trying
Ma'am,
to?
you are saying if,
Huh.
wherever in which column it is coming, that respective variable is linked to the first or second or third. In that way, you are saying, no?
You just need to see the correlation, and specifically in some
For example,
variable,
IF
some
one,
table
IF two is coming in component fourth, ma'am. Fourth.
uh,
So if that means that is linked to the fourth variable or what,
yes.
ma'am? How we will
So
interpret?
that means that IF has a correlation to four variable, number four variable. Okay.
Four variables or fourth variable, ma'am?
फोर ये कंपोनेंट में फोर वाला जो वेरिएबल होगा उसके साथ इसकी कोरिलेशन ज्यादा आ रही है. Then UP has a correlation with the second one. Okay, that means they are confirming that there is a correlation. See, the IF, ये सारे के सारे फैक्टर्स एक में शो हो रहे हैं. That means they are well correlated. मीन्स कि वो जो क्वेश्चन हमने अपने रिस्पोंडेंट से पूछे हुए थे वो सारे के सारे क्वेश्चन एक दूसरे के साथ भी कोरिलेटेड है. Okay. In UP this comes in second variable. That means कि whatever the question I asked to my respondent that are correlated, that has a correlation, good correlation with this constructs. ठीक है. एंड यहाँ GF के साथ प्रॉब्लम है कि GF, TF and RF they all are coming in one variable. That means somewhere there is problem कि वहां हमने GF में या तो कुछ ऐसे क्वेश्चन ऐसे पूछे हैं जो उसकी कोरिलेशन यहाँ दिखा रहे हैं. ठीक है. तो either it is show in somewhere in the here, और ये जितने भी वेरिएबल्स है उन सब में हर एक में ये वेरिएबल को शो होना है. ओके. सो what we can do, we rerun this. So we just eliminate some variables. We just eliminate the R1 and TF7. Okay, we just rerun. So we just go to again dimension reduction and then go for the factor analysis. Here we have all the variables in this plane. Then we just eliminate the R11, eliminate from here, and the TF7 values. Okay, so we here eliminate these construct. Okay, then we rerun. Okay, now come to this again. See, now we have TF, then GF, um, IF shows in four variable, UP comes in second variable, then again GF is pointing here, then all the TF, or we just need to delete TF1, 2, 3. Okay, 1, 2, 3 as well. We need to rerun. So this is a trial and error. Okay, So TF1, we need to eliminate this 2 and 3. Okay, 2 and 3. Um, please give me 2 minutes. I'm just coming. Yes. So we need to rerun again, and we eliminate this. Now see, the 4, 5, 6 has a value in 6 here. That means the TF is showing or having the correlation to the 6th variable. GF has GF has a correlation to one variable, and UP1 has second UP has correlation to the second variable, and so on. So you just need to rerun again and then check the correlations are coming or not coming, or if there is a problem, then you need to check uh, your Excel file here. So this is the Excel file. You just first need, if there is a values are coming with the same values, we just first check. We don't have any values here. Then we check the standard deviation here.